Okay, if you still not sure about that one, okay, I also share some video in our e-learning system there. Several system I obtained from the YouTube. Okay, several example of machine perspection or machine vision, autonomous machine vision system. Okay, let's discuss some of the videos. Okay, how about this one? Okay, this is an algorithm for brain tumor detection. Okay, let's go to the video. Okay, this is the video. Okay, they just skip there. Okay, you can see that in this video they develop the algorithm using the MATLAB. This is the GUI of the system, and the system is the purpose of the system is to detect or to recognize the tumor, the stage of tumor. Okay, from here you can see that the interpretation part is the input is image and the output is the tumor stage. So now you can see that you have the input image, the output is interpretation or the level of the image. So now actually this system is belong to a computer vision system. Okay, computer vision, because the input is the whole thing is called computer vision because the input is image, the output is interpretation. In this case the interpretation is a tumor stage recognition, and inside this system is involve a lot of process. You can see that they create a button there to show each and every block process there. One first is input image, the second is, you can see there's a pre-processing there, and then you know let's play the videos. Okay, you can see that they're applying the input image, and then they are using a segmentations there, and then you can see they apply the pre-processing. Okay, here the pre-processing, this is where the image and image processing involved, because now the input is image, the output is image. Okay, doesn't matter what type of approach there's a sharp image, the edge detection and so on. Any process or any approach, if the output is image and the input is image, that is where the image processing block involved, or the post or the pre-processing involved there. Okay, but in this case the post-processing is not involved. That's why it's not the slide that I showed before, which is this one. Okay, even I list up all the blocks there. Okay, that does not mean each and every process should be applied. In certain case, for example, let's say your image is you obtain from the image acquisition is good enough, no noise, zero noise, then you don't have to apply the pre-processing, you can directly apply the segmentation. So same goes to this case. Okay, in this case you can see that there's no post-processing. Okay, just pre-processing, and then I think there's also segmentations there inside, but they don't explain there. And then from oh sorry, the segmentation part is actually this one, edge detection, because edge detection is a one type of segmentation, because the region of interest is not the whole brain but only the wall, the wall of the brain. Okay, the tissue wall of the brains only, the border of the brain. That's why they apply the edge detections there. Okay, once they apply the edge detection, then you see that it's a feature extraction. So meaning that if the process is from here to here, where the input is image, the output is attribute, okay, then it is actually is image analysis. Okay, that's why you can see that what is the feature that they extract here. Let's go to the okay, I think they in this demonstration they don't reveal the features, the numbers there, but as you can see, when they obtain the features, they feed it into classification, where the classification in this case they are using artificial neural network, which is this one. Okay, you can see there after feature extraction, yep, this one, this is artificial neural network. Okay, they feed the output from this block into classification to detect the stage of the tumor. So that's why the final output there, you can see here, this is the label of the image. Once Okay, the label of image means that the input is image, the output is the label. Now this is the interpretation of the system. After you give the system with this image, then it provide this output, means that they give you some notification that this brain have tumor. Okay. Okay, this one is just, the rest is just to see the performance in terms of accuracy and so on. Okay, now let's go to other videos. Yep, this is another application. I think this is another application. Okay, you can see the same. They are using MATLAB to develop the whole system, the computer vision system. Okay, of course this is the old videos, that's why might be this at this during this time the AI is not so prominent, so that's why they are using the typical way to do the computer vision. First you need to do the pre-processing, segmentation, feature extraction, classification to obtain the whole system. But nowadays, because you have a deep learning, you just take one deep learning module called CNN, or convolutional neural network. You give the image, and the system or the network be able to interpret the image, so in one sub process only, while the previously we need to a lot of blocks there. That's why like I said before, because the deep learning still the input is image, the output is interpretations, so we also call that as a computer vision, which is also belong to computer vision community as well as image processing research community. Okay, but this one this one there's no deep learning, means that they are using the typical machine vision. They develop the process still using a conventional rules in developing the machine vision or autonomous machine vision system. Okay, same, they are developing the GUIs there, you can see there, and then you can see they try to load the MRI. Now this MRI image, and then this they just display the image over here, and then you can see, okay, in this case this is one of the case, the good case, where no pre-processing, means that no image enhancement involved. But does image processing involve? Yes, because without pre-processing, if you go back to this slide, okay, if I skip this block, I still have segmentation. So what is segmentation? The input is image, the output is also image, so meaning that this is as well is a image processing. Okay, don't confuse with that. Okay, without pre-processing, you still have a segmentation block, and segmentation block belong to image processing. So which is why in this case, okay, in this case there are no pre-processing, but you still have a segmentation process there. So that's why when they click that button, they execute the segmentation process. Now they highlight the region of interest, which is the tumor. Okay, tumor from the brain. And then okay, now okay, you can see that they already process it together. When they click this one, this is the segmented image after segmentation, and from this shape, actually shape of this white block, they extract these features, where actually this is come from feature extraction. So here is image processing, but if the input is image, the output is features, the whole system is image analysis. But these features, after that, they fit into some sort of because it's not mentioned in this video, I don't check the video in detail, but I just skip and I just forward, make it fast forward. So let's say this features is fit into A and N, and they train the classification block. The output of that is this one. That's why I said this the whole system is computer vision, because after they extract these features from these features they apply the classification to, and from that classification the output of that classification is this one. Okay, benign tumor is detected, meaning that they classified the or at this part type of tumor benign. So you can see that if you just, if the input is image, okay, and plus segmentation plus feature extraction, means the output is features, it become image analysis. But if the input is image, and then you apply segmentation, you extract the features, and the feature you feed into classification, producing the interpretation over here, now it's become computer vision, because the input is image, the output is interpretation. Okay, so the rest is, yeah, this how it's work. So I hope by showing you that two example, you can find any examples in YouTube or any sources, then try to, you know, try to identify by yourself. Have you already understand what is the difference between image processing, image analysis, and computer vision?